Bismillahirrahmanirrahim. Assalamu alaikum. This is Javed Iqbal, Assistant Professor, Government Superior Science College, Karachi. This lecture is actually divided into two videos. First video, we will discuss two of the rules for the electronic configuration. There are four rules for the electronic configuration. So in this video, we will discuss first two rules. There are four rules: Aufbau principle, N plus L rule, Hund's rule, and Pauli's exclusion principle. First one is Aufbau principle. It seems that Aufbau is the name of some scientist, but practically it does not mean so. It's a German word Aufbau, which means building up or to construct. Aufbau principle states that the electrons are filled in the orbitals in the increasing order of their energy. Like the orbital with lower energy should be filled first, then the higher energy, and so on. Like you can observe the sequence of the orbitals that 1s orbital should be filled first, then 2s orbital, then 2p orbital, then 3s and 3p orbital. So electrons are filled in the increasing order of their energy. This is Aufbau principle. Next is N plus L rule. But before going to N plus L rule, we have to discuss some discussion, and that is some points, that is what is the meaning of N, what is the meaning of L, and then we have to add N and L values. So let's find the N value and L value of each and every orbital. Actually, when we say 1s, 2s, 3s or 4s, it has some n value and it has some l value also. So for example, if we are talking about 1s, so in this 1s, 1 represents the n value, that is principal quantum number, and principal quantum number may be 1, 2, 3 and so on. Similarly, S represents L value, S orbital, P orbital, D orbital or F orbital. If these terms comes in front of an orbital, it means these represents the L value. L values mean azimuthal quantum number. Azimuthal quantum number has a value 0, 1, 2, 3 and 0 corresponds to the s orbital, 1 means p orbital, 2 means d orbital and 3 means f orbital. So if we are writing 1s, it means 1 is the principal quantum number, n value, and s is the azimuthal quantum number which has 0 value. For example, 2s means 2 is the n value and s has the 0 value, while 2p in 2p, 2 is the n value while p has 1 value. So let's find out the value of n plus L value of each and every orbital. So we are having 1s orbital, 1s has n value 1, L value 0, so n plus L value will be 1. 2s 2s orbital has n value 2, L value 0, so 2 plus 0 will be 2. Next is 3s. 3s in 3s orbital, 3 is the n value and 0 is the L value and 3 is the total n plus L value. Next is 3p orbital, 3p. In 3p, 3 is the n value, 1 stands for p orbital, so 3 plus 1 will be 4. Next is 3d. 3d mein 3 n value is 3, L value is 2, so 3 plus 2 is the 5. 4s has 4 value, 4p has 5 value. So we have find out in general some orbitals n plus L values. We can look at in the form of a chart also. So in this chart you can observe that we can find out each and every orbitals n plus L values. So these numbers in red shows the n plus L value. It's not the electrons, it's the n plus L values of each and every orbital. Now look at the n plus L rule, what it says. So statement n plus L rules statement consists of two parts. First part says orbitals are filled with the electrons in the increasing order of their n plus L values. It means the orbital with lower n plus L value will be filled first. Like we are having some examples. 1s has 1 value n plus L value, 2s has 2 n plus L value. So 1s will be filled before 2s orbital. Similarly, interestingly, you can observe that 4s orbital has 4 value while 3d has 5 value n plus L value. Therefore 4s will be filled 3d before 3d orbital. It's quite interesting, and examiners usually ask this type of electronic configuration in which 4s orbital is filled before 3d orbital. So why 4s orbital is filled before 3d orbital? The reason is 4s has 4 n plus L value while 3d has a 5 n plus L value, and according to the n plus L rule, the orbital having lower n plus L value will be filled before the higher n plus L value orbital. Second part of the n plus L value rule is if two or more orbitals have same n plus L value, then the orbitals are filled with electrons in the ascending order of their n values. For example, we just saw that 2p and 3s both have same 3n plus L value. So how can we fill these orbitals? You can observe that n plus L value of 2p is 3 and 3s has also 3 n plus L value. In this case, according to the n plus L rule, we have to fill 2p before 3s. Why? Because 2p's n value is 2 while 3s n value is 3. So lower n value we will consider first. In another example, 3p and 4s. 3p has 4 value, 4s also has 4 value, but the n value of 3p is lower than the 4s. Therefore, 3p will be filled first. Again, there are some examples 3d, 4p, 5s. These all three orbitals have same n plus L value. So they will be filled in the increasing order of their n value. Therefore, 3d will be filled before 4p, then 4p will be filled before 5s. Similarly, there are certain more examples 4d, 5p, 6s. All these three orbitals have 6 value. So 4d will be filled before 5p, 5p will be filled before 6s due to lower number of their n values. 4f, 5d, 6p, 7s, all these four orbitals have 7 n plus L values. So 4f will be filled before 5d, 5d will be filled before 6p, 6p will be filled before 7s. So look at the chart again. You can observe that we had a rule or an arrow method, and this arrow method can be seen in this chart also. Like 1s is filled before 2s, 2s is filled before 2p, and so on. So arrow method is actually n plus L rule. Behind arrow method, arrow orbital diagram, we can see that it's n plus L rule. Now there is a question usually comes in exam, that is they give some wrong electronic configurations and we have uh, to correct them, and we have to find out which rule or principle is violated. For example, in case of Aufbau principle, which type of incorrect electronic configuration may arise? Like hydrogen's electronic configuration, atomic number 1, and the electronic configuration given to us is 2s1, which is wrong. We know that. So it is wrong according to the Aufbau principle. Why it is wrong? Because according to the Aufbau principle, we have to fill the electrons with orbitals uh, we have to fill orbitals with electrons in the increasing order of their energy. So the lowest energy orbital is 1s orbital. Therefore, the electronic configuration of hydrogen should be 1s1 instead of 2s1. This is according to the Aufbau principle. There is another example, that is lithium having 1s2 3s1. There is an skip of two orbitals, that is 2s and 2p orbitals. So this is again wrong according to the Aufbau principle. Aufbau principle says electrons are filled in the increasing order of their energy. So we had the correct configuration, that is 1s2 and 2s1. Next is some examples for N plus L rule. This is incorrect electronic configuration. Potassium atomic number 19, 1s2, 2s2, 2p6, 3s2, 3p6, 3d1. We know that we can write the correct electronic configuration, but we have to find out which rule or principle is violated in this electronic configuration. We just saw that after 3p the orbital, that is 4s, comes, but in this electronic configuration 3d is written, so correct electronic configuration is this one. Why this electronic configuration is incorrect? Due to the n plus l rule. 4s orbital has 4n plus l value, while 3d orbital has 5n plus l value. So according to n plus l rule, 4s orbital should be filled before 3d orbital, as 4s has 4n plus l value while 3d has 5n plus l value. There is another example for n plus l rule, that is magnesium's electronic configuration is 1s2, 2s2, 3s2 and 2p6. Why this electronic configuration is incorrect? Because 3s has n plus l value 3 and 2p also has n plus l value 3. Why 2p is filled before 3s orbital? Because n plus l value, both the orbitals have the same n plus l value, but 2p orbital has lower n value, therefore 2p orbital should be filled before 3s orbital. So this electronic configuration is incorrect according to the n plus l rule. Now look at the correct form of this electronic configuration. So this is all. Thank you very much.